Hello and welcome to this new tutorial. Now we are going to mine a new block by making a new request now that we have our Flask-based web application. So, to start this, let's go back to the Flask quick start I introduced to you in the previous tutorial. Here we are on this quick start. What we've done already is create the Flask-based web application by creating an instance of the Flask class, and now as it says very clearly on the documentation, well, the next step is to use the root decorator to tell Flask what URL should trigger our function. And our function will be to mine a block, which we'll call mineBlock. So what we need to do now is start with a root decorator. We will specify which URL will trigger our mineBlock function that we're about to implement, and then we'll just implement that function. So let's do this. Let's copy this now, because that's the decorator we need to start with to make a request. So I'm copying this, and now let's go back to Python to start mining our new block. So I'm pasting that here, the decorator, and now, so after this slash here, we need to specify this URL, which is basically an address to call when we want to apply the mineBlock function to mine a block. And so we will call this part of URL mineBlock. mineBlock, and before the slash, you can wonder what will be before the slash. Well, there's going to be the whole URL address. And if we go back to the quick start, we can see what this address is. That's the full URL, http://127.0.0.1:5000. And after this 5000 slash, well, we will add mineBlock, and this will be enough to send the request to mine a new block. Alright, so we have our decorator. We just input the mineBlock part of URL to mine a block, but then we need to add another argument, which is the method of the request. And so what is this method going to be exactly? This is going to be an HTTP method for which we also have some documentation. You see in this routing category, you have here HTTP method, so I just clicked on it, and here you can find all the information of the different requests you can use in Flask to accomplish some actions. And so, since now we're about to make a GET request, because the difference between GET and POST is that GET will only get you something, basically, and POST will create something. So we'll use the POST method in module 2 when creating some transactions with a JSON file. But here, we just want to get a new block by first mining it, and therefore we'll only need the get method here to get this block. So now what we simply need to add besides our first URL argument is this method, and we will only take get, because as we said, we don't need the post request yet. Alright, so I'm copying this. Now let's go back to Python. Here we are on Python, and let's add a comma here, and then this second argument, method equals, and we just need get. And that's it. We are ready to start implementing our mineBlock function. Let's do this. So we start with def, because we just defined a new function. Then we need to give a name to that function, which will be mineBlock. The mineBlock function, which won't take any argument, because you're going to see that we will get everything we need from our blockchain object. So mineBlock with no argument. And now let's start defining what this function has to do. So what does it have to do exactly? Well, it has to mine a block. And how do we mine a block? Well, we first need to solve the proof of work problem by finding the proof based on the previous proof, that is the last proof given in the last block. And then once we get this proof, well, that means that basically we succeeded in our mining. Once we get that proof, well, we'll get the other keys we need, that is the keys required to create a block. And these are the index, the timestamp, the proof, and the previous hash. Alright, so let's do this. Let's start by getting this proof by solving our proof of work problem. So, in order to get that proof, well, of course, we'll apply our proof of work function. But in order to apply our proof of work function, we need the previous proof. And therefore, the first step we need to do here is to get that previous proof. And good news, we have this get previous block function that will get us the last block of the chain, from which we will get the previous proof, because we will just need to take the proof key of its dictionary. So let's do this. Let's start by getting the previous block, which we can get by taking, of course, first our blockchain object, and then, as we just said, call the get previous block method. That gives us the last block of the chain. Now we want the proof of that previous block because we need the previous proof to call the proof of work function. So let's get that previous proof, and we get this by taking, as we said, our previous block and then the proof key of this previous block. So that gives us exactly the previous proof. And now that we have this previous proof, well, we can call the proof of work function because it takes only this previous proof argument. So let's get our proof by calling the proof of work method from our blockchain object, from which we call the proof of work method of the previous proof. And that gives us exactly the proof of our future new block that will be added to the blockchain. So now we have our proof. Perfect. Now let's just get the other keys we need to create this block and add it effectively to the blockchain. So remember, how can we add a block to the blockchain? Well, we made a function for that, which we called createBlock, that not only returns a block, but also append this block to the blockchain, to our chain. And so now the question is, what do we need to call this createBlock function? Well, we just need the proof, which we already have, and the previous hash. So now what we need to do is get this previous hash. So let's do this. Let's get the previous hash now. So previous hash, and to get it, well, of course, we take our blockchain object again. And now, what do you think we should do? Well, we made the right method for this. Remember, that's why I told you we needed to make it separate, because we would need it in part 2. That's exactly the hash method that hashes a block, and therefore here will give us the hash of the previous block, which is exactly what we need. So we get our previous hash, we have the proof, perfect. Now we can call the createBlock function to append this new block that was just mined by the miner to our blockchain. So let's do this. Let's call our createBlock method, but since it is a method, we need to call it from our blockchain object. And from this blockchain object, we call our createBlock method, which takes as argument the things we already collected, that is the proof and the previous hash. Awesome, but remember that this createBlock function returns the block that was just mined, and therefore we will add here block equals to what this function createBlock returns. Great. And so since we have our block not only appended to the blockchain, but we also have it returned, well, let's display it in our user-friendly interface Postman, which we'll use at the end of this module when doing the demo, in a response to this GET request. So here I'm introducing the response variable, which will contain not only all the informations of the block, but also a nice message congratulating the miner for mining a block. All right, and speaking of this message, this is what we'll start with. So we're going to return this response displayed in the Postman interface in the JSON format, and therefore here I'm making this response a dictionary. And that's why we'll include the keys of the block that was just mined, with their values of course, but also we can add some other keys because this is a new response dictionary we're making, and this extra key will be this message that we give to the miner to congratulate him. Congratulations, you just mined a block! Exclamation mark. Congratulations, you just mined a block, and your block will be added to the blockchain. It's yours. So let's not forget to close the quote and add comma, and now we're going to add the other keys. So the other keys are simply the keys of the block, which are exactly the index, the timestamp, the proof, and the previous hash. So let's add them one by one, starting with the index. And to get the index, we take our block, and from this block we get the index key, very simply. then comma, then the next key is the timestamp. So timestamp here, that's the key, and to get the value of this key we take our block again and the timestamp key. So just to make sure we understand, this is the key of the response dictionary and this is the key of the block dictionary, right? So here we're just making a new dictionary but taking the values of the block dictionary. The next key, proof, which we got at the beginning of this function. So proof, and again we take our block, and from this block we get the proof key, which will give us the proof value. All right, and final key, the final key is, of course, the previous hash. So previous hash, in quote, colon, and to get the previous hash we take our block, and from this block we take the previous hash key. All right, and now we have all the keys that define this new block that was just mined. And now the last thing we need to do is to return this response so that it can be displayed in our user-friendly interface Postman. And to return this, well, since it's a function, we need to finish it with return. And we're not going to return the response directly. We're going to use the JSONify function to return the response in the JSON format. And we'll also return something else, which is called an HTTP status code. And to show you what they are, I'm going to go back to Google, not on this Flask documentation, but on a new tab. We're going to type here HTTP codes. Here we go, enter. And it should be the first link. There it is, the classic Wikipedia list of HTTP status codes. And here you have all the codes, and that's exactly what we have to return right now. And what we want to return is a code for success, meaning that everything is okay, the block was just mined, added to the blockchain, and basically there is no error, so we can display the response message to our GET request. And so the code we want to include right now to say everything is okay is this one, the 200 code, which means basically okay. And as you can see, it's the standard response for successful HTTP requests, which is exactly what we just made, an HTTP request. And the actual response will depend on the request method used. In a GET request, the response will contain an entity corresponding to the requested resource. And then in a POST request, which will made in module 2, the response will contain an entity containing the result of the action, which you will see will be to create a transaction and even to create a new node in our decentralized network, because I remind that in module 2 we will decentralize this blockchain that we're making right now. So that was just a few words on the HTTP code, and that's exactly what we also have to return right now. So let's go back to Python and let's add this 200 HTTP status code to say that everything's okay. All right, congratulations, you just made your first function to interact with our blockchain. Now in the next tutorial, we're going to make another function, which will be the getChain function, which will be based on another GET request to get the whole blockchain displayed in Postman. We'll do that in the next tutorial, and then we'll be ready for the demo. I can't wait, and until then, enjoy blockchains.